The group 2 metals are the elements in group 2 in the periodic table and are beryllium, magnesium, calcium, strontium, barium and radium. They are also called the alkaline earth metals. Alkaline as their compounds tend to form alkaline solutions with a pH greater than 7, and metals because, well, they are metals. As they have only 2 electrons in their outermost shell, they commonly form ions with a 2+ charge. As you go down the group, the atomic radius of the atoms of each element get larger, meaning the atoms are getting bigger. This is because there are more inner electron shells, increasing the level of inner electron shielding and forcing the outermost electrons to be further from the nucleus, increasing the size of the atom. Another important trend of the group 2 metals is that melting point decreases as you go down the group. To explain this trend, we need to remind ourselves that in metals, atoms are held together by metallic bonding, described as positively charged ions attracted to a sea of delocalized electrons. To melt a metal then, these forces of attraction between the positively charged ions and delocalized electrons need to be overcome. And the stronger this attraction, the more energy that is required and the higher the melting point of the metal. A high charge to mass ratio of the positively charged ions means stronger attraction. Essentially, the bigger the charge and the smaller the ion, the stronger the attraction. Group 2 metal atoms all form ions with the same charge, 2+. However, the elements at the top of the group have a much smaller atomic radius than elements at the bottom, meaning the nucleus is closer to the delocalized electrons, increasing attraction to them and giving stronger metallic bonding, increasing the melting point. For example, beryllium has a high melting point of 1511 Kelvin, and barium is much lower with a melting point of 998 Kelvin. Magnesium actually has a lower melting point, 922 Kelvin, than calcium, 1112 Kelvin, meaning magnesium doesn't follow the trend of the other group 2 metals. This exception is generally believed to be due to magnesium atoms being arranged in a slightly different way to the other group 2 metals in a solid lattice, decreasing the level of attraction between the positively charged ions and delocalized electrons, making the metallic bonding weaker, giving magnesium a slightly lower melting point than we would expect. I hope you found this video helpful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.